Oh, hello. I almost did not see you there. It is time to discuss how we calculate the mass of planets. First person we will be talking about is Johannes Kepler. And Kepler's third law states of planetary motion establishes the relationship between the average distance from a planet to its sun and the time period it takes the planet to orbit around the sun. The distance is called the semi-major axis, which is represented by either the variable r or a. The time it takes is called the orbital period and is represented by the variable p. Kepler's third law stated that the orbital radius cubed is equal to the orbital period squared. Kepler's third law came across two major problems, which were that, one, he had no idea why and or how his equation worked, but that it worked in general. Seemingly not very smart. Kepler's equation also only worked with planets that orbit the sun. And that is when, skadoosh, Isaac Newton comes into play. Isaac Newton solved Kepler's problems by introducing his theory of gravity and establishing the importance of the mass of the objects. Newton developed a more general form of Kepler's third law, and it also seemed to work with moons orbiting planets and planets orbiting suns and other things orbiting things and black holes and. Newton's addition to Kepler's third law generated the proper and more specific equation for calculating the mass of planets. The final equation that Newton had come up with was that the mass is equal to 4 pi squared over the gravitational constant multiplied by the orbital radius cubed over the orbital period squared. The m, of course, is the mass, and the g, of course, is the gravitational constant, which is 6.67 times 10 to the negative 11th power. The mass and gravity was given to us by Isaac Newton. The orbital radius cubed is, of course, the distance that the planet or moon is orbiting around the sun or planet, and that becomes cubed, and then is over the orbital period squared, which is the time it takes to orbit around the sun or planet. Next, I will be doing the demonstration of finding the mass of Jupiter in a demonstration. This, in a demonstration, is the planet Jupiter, whose mass is unknown to us right now. And this is one of Jupiter's moons, Io. Jupiter's moon, Io, has an orbital diameter of about 4.216 times 10 to the 8th meters. And its orbital period is about 1.769 days, which is, in seconds, 1.528 times 10 to the 5th seconds. Here you go, Jupiter. I will now show the process used for calculating the mass of Jupiter in kilograms by using Newton's newer version of Kepler's third law of planetary motion. With what we know about Io, well, kind of, you could look it up, is that its orbital radius is about 4.216 times 10 to the 8th power meters. Its orbital period in days is about 1.769 days, and converted to seconds, of course, is about 1.528 times 10 to the 5th seconds. The gravitational constant given to us by Isaac Newton is about 6.67 times 10 to the negative 11th power. The equation is as follows. The mass of Jupiter is equal to 4 pi squared over the gravitational constant times Io's orbital radius cubed over Io's orbital period in seconds squared. It then becomes simplified without showing you the complicated math. It becomes 5.92 times 10 to the 11th times 7.494 times 10 to the 25th, which is the orbital radius, over the orbital period, which is 2.335 times 10 to the 10th. The calculated mass of Jupiter is, of course, then 1.899 times 10 to the 27th power kilograms. This equation is important to astronomers because they can obviously not physically weigh the mass of the planets, the stars, or the sun as easily as we can weigh the mass of this basketball, this ball, or ourselves. Well, now that we're done with the smart and math stuff, it's time to talk about the weird. First off, Johannes Kepler. His grandmother was tried in the Salem witch trials, found guilty, and burned at the stake. And following that, his mother was accused of witchcraft for her medical mysteries. Next, Isaac Newton. Isaac Newton tried to burn down his house with his own mother inside, because he was kind of a psychopath. Which makes you think, should we really trust his theory on gravity?